So if you get a problem in general about collisions, the first thing you're going to do is to sketch a diagram if there is no diagram already given to you. And when you do that, you need to do it with respect to some coordinate axis. So you're going to define which is your x and y direction. Okay, if the motion is happening only in one direction, you only need the x-axis. And you're going to set up your origin to make it easy for at least one of the masses, right? So you might want to center it on the mass of one of them or center it at the point of collision. Okay, that's your choice. You want to choose your origin and your coordinate direction to make your velocities lie along the axis as far as possible in a positive or negative direction. Okay, then you're going to sketch out that diagram. Okay, you're going to use, first of all, the conservation of momentum, since that has no squared terms. So that's an easier equation to use, and it always applies. So you're going to use the condition for conservation of momentum, since this always happens in every isolated collision system. Okay, going to get the initial and final momenta and set them equal to each other. If that is insufficient for solving your problem, you might consider the conservation of total energy if your system is isolated and there are no non-conservative forces. Or if you have an elastic collision, sorry, beg your pardon, if you have the case of an elastic collision, so if you have the case of an elastic collision, then the kinetic energy is conserved, and you will apply that conservation of kinetic energy as your second equation, okay? And you will solve the equations simultaneously after that, okay? So the sketches for collision are always a before collision picture and an after collision picture. So here's my before collision, here's my after collision. I've marked out the x direction, the positive x direction. This already tells me that the value of this is going to be a negative number. This is going to be a positive number. Now, okay. And then for the case of perfectly inelastic, you're going to do exactly the same kind of thing. This is the easier case where your two velocities for the initial system, your two momenta, you're going to get them from your initial system, and you're going to set them equal to the final one momentum, because it's a combined momentum for the two objects moving together. So in the perfectly inelastic case, you are always going to have just one final velocity, okay?